Hi there, Mr. Sutton here, bringing you the Pre-Cal Honors 2-1 Extra Practice Number 2 solutions on solving polynomials by factoring. For this problem, first I tried taking out a common factor, which is a complete fail. Since that didn't work, I noticed that I have 4 terms, so I can try factoring this by grouping. If I take out a common factor from the first 2 terms, it looks like I can take out an x squared. That leaves me with 2x minus 3. And then for the next 2 terms, those are both divisible by 9, and that would leave me with a 2x minus 3 as well. Taking out my common factor of 2x minus 3, that leaves me with x squared plus 9 as the other factor. And at this point, I can set each of these factors equal to 0 and solve. If 2x minus 3 equals 0, adding 3 and dividing by 2 gives me 3/2 as a solution for that. And then if x squared plus 9 equals 0, well, that means x squared equals negative 9 if I subtract that 9. And then square rooting both sides, I can take out an I because I'm square rooting a negative, and then the square root of 9 is actually 3. And don't forget the plus or minus, so a lot of things going on. This is going to be x equals plus or minus 3i. To solve this one, we can't take out any common factors. But if you notice here, we have x to the 4th, x squared, and a constant. That's quadratic form. So I'm just going to factor this thing like I would factor a quadratic, but I'll use x squared wherever I would normally use x. So looking for factors now of 35 that add up to 12. 1 and 35 doesn't work. The only other option is 5 and 7. And 5 plus 7 adds up to 12. So I can split this up into x squared plus 5 and x squared plus 7 equals 0. And now setting each of these equal to 0 and solving individually, if x squared plus 5 equals 0, x squared must be negative 5. And then if you square root both sides of that, we have a negative inside a radical, so that can come out as an I, giving us x equals plus or minus I radical 5. And then for this next one, we have x squared equaling negative 7. Square rooting that, pretty much the same idea as that first branch. We have x equals plus or minus I radical 7. On this problem, I notice right away that I can take out a common factor of x. I'm always looking to take out common factors. So if I do that, that leaves me with x squared minus 2x minus 15. And now that quadratic can be factored inside there. So factors of negative 15 that add up to negative 2. Well, 1 and 15 doesn't work. 3 and 5 does, though. If we have positive 3 and negative 5, so I can split this up with an x plus 3, and an x minus 5. Setting each of these factors equal to 0 and solving, we have x equals 0, x equals, for this middle factor, negative 3, and for this last one, we're going to have x equals 5. On this problem, I notice right away that I can take out a common factor of x. Doing so leaves me with x squared plus 7x plus 12. And this quadratic inside can be factored pretty quickly. We just need factors of 12 that add up to 7. 1 and 12 won't work, neither does 2 and 6. 3 and 4 works. So I can bring down that x, and then I'll have x plus 3 times x plus 4. Setting each of these equal to 0 and solving, we have x equals 0 for that first x factor. And then for this middle factor, x must be negative 3. And for this last one, we have x equals negative 4. For this problem, doesn't look like we can take out any common factors, but since we have 4 terms, we can try grouping. For the first 2 factors, looks like I can take out an x squared. That'll leave me with x plus 1. For the last 2 factors, or terms rather, I can take out a negative 3. That leaves me with an x plus 1. Well, since I have a repeated x plus 1, that comes out as a common factor. And now I have x squared minus 3 as my other factor. Setting each of these equal to 0 and solving, if x plus 1 is 0, that means x is negative 1. If x squared minus 3 is 0, well, I can add the 3 and write x squared equals 3. And then I can just square root both sides to get x equals plus or minus radical 3. For this problem, I can't take out any common factors, but I notice we've got x to the 4th, x squared constant. That's quadratic form. So I'm just going to try factoring this like a quadratic, and I'll use x squared wherever I would normally use x. So factors of negative 16 that add up to negative 6. 1 and 16 doesn't do it, but how about positive 2 and negative 8? That would add up to negative 6. So I can split this up then with x squared plus 2 and x squared minus 8. Now I set each of these factors equal to 0 and solve. If x squared plus 2 equals 0, we can write x squared equals negative 2, because you would subtract 2 to start solving that. And then square rooting both sides of that equation. Well, I'm square rooting a negative, so that can come out as an I. So that's going to be x equals plus or minus I radical 2. For this next one, we can write x squared equals positive 8, because 8 minus 8 would give us 0. And then square rooting both sides there, I can split that radical 8 that I'm going to get up into a radical 4 times a radical 2. So I've got plus or minus radical 4 times radical 2, which I can simplify to just plus or minus 2 radical 2. On this problem, I noticed pretty quickly that I can take out an x from everything. That's always the first thing I try to do. So if I take out an x, I've now got x squared plus 3x plus 2 left inside. And I can factor that one pretty quickly. We just need factors of 2 that add up to 3. Well, 1 and 2 is it. So we have an x plus 1, and an x plus 2. And just setting each of these equal to 0, we have x equals 0 for that first factor, negative 1 for the second factor, and negative 2 for that last factor.